URC has been around. This is the 10th year for the competition. Been around for a while, but it predates that even further. It goes all the way back to when I was a lowly undergrad, when I was at Penn State. When I was there in the spring of 2000, got involved in a student group that was doing a NASA-sponsored design competition, and we're working on the design for a robotic mission to Mars. Through that, and the professor that was in charge of that group at Penn State got involved in the Mars Society. Around that same time was when the Mars Desert Research Station here was coming online, and they were doing all these simulated missions here. And that really seemed to be a great opportunity for some research for a group of undergrads to get into. So we started working on a Mars Rover assistant that could be controlled through virtual reality gloves. And as this project progressed over the years, eventually we ended up in the spring of 2004 coming out here as a student crew. And our rover wasn't terribly successful at the time, but just coming out here and participating in MDRS was a tremendous opportunity. After that, I graduated Penn State, and a few of the students behind me were continuing to work on their rover. But based on what they were doing there, Robert Zubrin, president of the Mars Society, was really excited about the idea of students building rovers and bringing them out there. And at one of the conventions, I think in 2005, he had the idea that, hey, we should really set up a competition for college students to build their rovers, bring them out to MDRS. It's the perfect setting. It just seemed like a great idea. And of course, I was in the room at the time, and oh, this all sounds like a great idea for things that I'm passionate about. Of course, I had the brilliant idea at the time, oh, I'll help with that, raise my hand. And yeah, that's kind of what was the impetus for URC. So we kicked off URC about a year later after a good bit of research. In August of 2006, first competition was in late spring, early summer of 2007. And then fast forward to 2016, our 10th year, with 30 teams, 63 that have been competing since the beginning of the year. It's just been tremendous to watch it grow over these years. I don't know if I even have a good answer for why this competition has taken hold as well as it has. It's easy for me as somebody who has a background in robotics with a focus on Mars exploration. Sure, everybody should be passionate about it, but the hold that it's taken has really been beyond what we could have expected. And I think really what has helped the growth has been the excitement of the students. If you give students an ambitious goal, something that's on paper probably too hard for a group of students to accomplish in a year, they love to take that challenge and prove you wrong and prove to themselves what they're capable of. And so we've really tried to set this competition up to empower the students, to give them a lot of creative potential with where they take their systems. And I think that has really manifested in the excitement they get from each other, the excitement they get within the team. And they bring it to the field. You see just how passionate all of these students are.
So in September, URC releases the rules and regulations, and generally we will sit down and, after everyone has read through them, kind of have a brainstorming session and decide what we need to improve from last year, how we should adjust our current design to accomplish the goals of the competition.
Reviewing previous designs, talking to people who were on the team last year, what they found at competition, what went wrong, what we did well, and then just kind of making a list of what we need to actually achieve this year, going through the rules, and it's really just requirements gathering at the beginning.
We really leave it as an open design envelope for the teams to explore what makes sense for the task. We put a lot of time into defining what's required of the rovers in the field operationally, but then teams have to go through sort of the systems engineering process where they're establishing requirements, figuring out what the different subsystems on the rover need to be.
The actual Mars Rover team is structured into divisions. We have 4 of them. We have the mechanical, the electrical, and the software and science division. And each of them are divided into sections.
And what they do is they'll split up into groups for the week and kind of work individually on tasks that are specific to them. And then we all come together for a meeting on Wednesday where we sort of hash out what we've done in the past week and then what our goals are for next week and make sure that all the teams are on the same page.
Having such a structure allows us to have a better work distribution and better communication scheme across the entire team.
So I think one of the interesting things that a lot of people don't really think about is how much designing actually goes into building the rover. We really only have a completed rover for a small percentage of the year. It just shows that there's definitely a lot that goes into the planning of that.
We first looked at all of the designs of every other team that would previously participate in URC. So it was just collecting a lot of data, doing a lot of research on, what did they do? Did that work or did it not work? And then from there, we tried to develop our own designs and our own concepts.
We wanted the rover to have hill climbing capabilities, to be able to traverse over rocks, and also minimize the vibrations on the robot. So once we found a design that fulfilled all of these design requirements, we settled on the design.
So a simple design is usually the best design because everything that can go wrong will go wrong at competition, so you want to minimize the number of things that can go wrong.
You don't really think about what these sort of outside obstacles might be until you're there. And when you keep everything just simple as it can be and just have basically a rover with an arm, something that just drives the way you want it to drive and does what you want it to do, it makes it a lot easier for fixing whatever goes wrong.
It's really down to reliability, because once you get down to competition, you don't have the same tools that you have here to be able to fix it, or you don't have a CNC machine or a 3D printer, so you really have to make your designs as simple as can so you can repair them and they don't break as easily.
So a lot of my role is doing research. I've done that by just looking at scientific papers, basic stuff like that. A lot of looking on NASA's website. They have a lot of good resources and sources.
We have some engineers and some science students, and then we start off with kind of background research on Mars and geology, chemistry, life, all that. And then from that, we design our experiments for the competition. A lot of our ideas are based on Curiosity rover and some of the other rovers that got shut down for funding reasons. So we're trying to mimic what NASA's doing to find that. Obviously we don't have quite more limitations than they do, a lot less money, but I think it's very important to kind of expand and see if life exists at other places than Earth.
As engineers, I think it's a little bit hard to lose sight of why we do this. We build these machines for scientists to use on Mars. So I think it's the challenge that they do is really applicable to what NASA does. Is scientists come up with tests that they want to run, and from their point of view, they may not realize what the engineering behind it is. They just want to run these tasks, and as engineers, we have to go and we have to realize, okay, well, what do the scientists want? How can we help them achieve their goals? So there's very much a conversation there that I think they're trying to get us to do. And that's what happens in the real world. You want to test for a particular life form in whatever soil, and you know that it's going to be hard soil. So you go to the people who build the rover and tell them that and hope that they can make the device that'll allow you to get that test done.
If you look over the 10-year history of the University Rover Challenge and you compare some of the early rovers with the systems that are being fielded now, it's amazing to watch this evolution in what is considered a student Mars rover. Now, if you look at a lot of the rovers that come in, you see a lot of different manufacturing techniques. Some of these rovers and teams, they'll have access to pretty high-end manufacturing techniques, whether that's working with Protocase or if they have their own in-house capabilities.
So Protocase is this one manufacturing company that offers services for everyone, and from a student point of view, that's incredible, because very often when you reach out to a company, they're actually expecting your whole design to be done actually to specific standards that will match all their services actually, and they don't want to put any more work into what you're giving to them.
Just the process of going from our initial ideas to having feedback from Protocase to continuously iterating on it to actually have something that makes our robot look a lot more professional. It's easier to use. It's been a huge asset for us.
One of the big drawbacks we had the first year that we did the competition is that we had to fabricate everything in-house, because it would have been cost prohibitive without a sponsorship to do it elsewhere. And Protocase has been an incredible help, and we would be much further behind without them.
When we get to an actual much more serious rover that's being built, whenever we have a new mechanism that's coming in, we start testing it, and very often there's some tiny details we need to readjust, and that's why testing is so important. So it actually allows us to just pinpoint each of the problems along the way and solve them, and hopefully in the end, on the line, when we go to URC, we have almost none, and we're able to run. We were inspired by a testing platform from the University of Toronto, which was basically a system of railings that was hanging a wheel, and they could actually just drive single wheels and try different traction system and different wheel sizes. And with a bunch of sensors, they gather a bunch of data, torque, thrust, translational motion, and everything to know what's going on and what's the best wheel system. So, Toronto, thank you.
So this is a robotics competition that is probably 30% robotics and 70% logistics. Organizing a team to get out there to such a remote location is pretty tough.
We've come to Utah from different places because a lot of people have things that they need to do over the summer. But definitely this year, we're probably going to aim to have some people sort of around Yale finishing up the last things on the rover so that we can all travel down there together.
Currently, the whole team is packing up in our custom boxes we got from Protocase, which is a boxing company that's made for transportation. And some of the people will be driving with the box all the way down there, and most of us will be flying soon at the Mars Desert Research Station.
The 4 rover competition task, there's a science analysis task that takes a slightly different theme each year, but a rover will actually go out, do physical measurements on the ground with the rover, oftentimes collect a physical sample that'll be returned for later analysis by the crew. There's a terrain traversing task, which is probably our most exciting task, and actually the wonderful landscape behind me right now with all the incredible hills and cliff edges and boulder fields and you name it, it's out there. We set up a number of gates across the field, and teams have to navigate their way across the field. And you may think it's simple, just drive to a gate and drive through, but when we put one up at the top of a rather steep 45-degree climb, or force teams to go over a 1-meter sheer drop-off, or drive across a boulder-strewn field to get to a gate, it makes things pretty challenging for the teams. It really stresses the overall navigation capabilities of the system. There's an astronaut assistance task where a rover will have to pick up tools that are laying in the field and deliver them to astronauts, or in this case, just dummy suits that are sitting out in the field where an astronaut would theoretically be waiting for a tool that they need. And then there's an equipment servicing task. Anytime you have a large expedition anywhere, and an eventual human mission to Mars, there's going to be a lot of equipment involved. And that equipment's always going to need maintenance on there. So in this case, they'll use their rover to go out, and there's an arbitrary panel out there. It requires a lot of very fine motor control, dexterous manipulation to work, whether it's turning knobs and valves or flipping switches. But they essentially have to walk up to a panel they've never seen before and figure out how to operate it through this rover. In between tasks, teams really have a good deal of time, and they're only competing twice a day at most, so they have a lot of time in between events to either unwind or in some cases scramble if they're winding up trying to get some of their systems fixed for the next competition. And really what teams are doing comes down to how well prepared they are coming into the competition and how well their rover worked during the last task.
The competition during the day is usually very stressful. We break things. We're always struggling really hard to get everything to work perfectly the way we designed it. So we like to de-stress a little bit after each competition. We'll go have dinner somewhere, then go back to the hotel. If something's broken, the people who know that system will try to fix it. And that's part of why I really like QSIN and why I've been with it for 3 years, is the hacking stuff together. It's one thing to have all your resources that you would on campus, screwdrivers, hammers, everything. But it's another thing to be there, have something broken, and all you have is the corner store to grab a spoon that you could drill a couple holes in and use it to attach two pieces together.
And it's definitely a lot of fun once you're finished getting to interact with the other teams, because obviously, you know, it's a competition, everybody's going against each other, but really the atmosphere down there, it's not about competition, it's about everybody trying to do their best and trying to improve themselves, improve their rover. So everybody's willing to help out all throughout the competition. But especially at the end, there's just this really cool bond between everybody because you've been working on the same things for so long.
We don't always have the chance to talk to everyone down there in the desert. People spend most of their time back at their hotel working on their rover. And if you're not at the same hotel as everyone else, you don't get to talk to them very often. So we'd like to have this time where people just comes together after the actual barbecue organized by URC, just to start celebrating.
3, 2, 1, go! Oh my God!
The University Rover Challenge is that ultimate competition field any Mars Rover designers would love to go and compete in. It's not just a small simulated, encapsulated environment, it's also an open wide environment that is very similar to what we have on Mars, so it's a great place to test your rover in.
Probably wasn't a surprise if you were paying a lot of attention. We've got back-to-back champions, legendary rover team from Poland. And ladies and gentlemen, it is now my privilege to announce the URC 2016 is officially over. Thank you, gentlemen.
We look at the success that some of these students who've won in previous years are having in their professional lives now, starting to become leaders of industry in robotics and space systems. It's really exciting to see what they're capable of.
I was on other design teams in my first year, and it was just kind of, their competitions are every year it's the same kind of thing. You don't redesign, it's just doing the exact same thing or iterating on a small part, whereas URC has been like incredibly difficult, which to most people I think I would push them away, but for me it's kind of like that challenge is awesome. Doing something that at the beginning you're like, I can't do this, but then gradually improving until you can.
And I think it's been great to help with publicity, help promote the overall cause of STEM education, space exploration, creating awareness and advocacy for those causes, which are really at the heart of what we do here. So what we've learned, what we've been able to incorporate back in, it's everything from how to manage a single event to how to scope the requirements for the teams to succeed, and then again, opening up things to more competitions around the world. We're on a great path to continue doing great things through this, and it's a lot of excitement and potential going forward.